And that's what we used here. A to the 5th squared is A to the 10th. B squared squared is B to the 4th. Okay? Power of powers property. Here's two more rules, and I don't have a distinct name for them, but unless you want to call this the reciprocal of powers. That's not a powers. Oh no, what's up, Mr. Bill? I'm really messing up now, aren't I? So this is the reciprocal of powers. Reciprocal of powers property. How does it work? Well, if you have a base raised to a negative exponent, you can simply take the reciprocal of this. A over 1's reciprocal is 1 over A, and then raise it to the positive power instead. So A to the negative R power is the same as 1 over A to the positive R power. Here's an example. 2 to the negative second power is the same as 1 over 2 to the positive second power, which ultimately is 1 over 4, 1/4. Another example. This is like a combined example, okay? So we've got the power of an exponent, but we also have a negative exponent. So that means first we can change this to 3 to the negative second power over 4 to the negative second power. And then the property we have here is the reciprocal of powers. We can simply take the reciprocal of 3/4, which is 4/3, and make these powers positive. Or, that is, switch them. So if it's 4 to the negative second power down here, it becomes 4 to the positive second power up here. 3 to the negative in the numerator is 3 to the positive second in the denominator, leaving us with 16 over 9. And we basically can call this the reciprocal of powers property. Then there's two more that we need to talk about. One is the zero exponent property. The zero exponent property simply says anything raised to the 0 power is 1. Why is that? Is that just some arbitrary thing? No, it goes back to this number that I keep referring to, this really magical number, this really super cool number that we have in mathematics. Anybody remember at all ever hearing me say anything vaguely like this magic number? 1. So if you keep that in mind, whenever you have a base, there's a 1 in front of it. That is 1 times how many of these? 0 of them. So 1 times, basically, nothing there. Not a 0, but nothing there. 1 times, well, it's 1. That means it's some number like this. 16,285,000 to the 0 power is just 1. Anything to the 0 power is 1 because of that invisible, magical 1 that is always present. The other one is what we can call the 1 exponent property. The 1 exponent. Notice the 1 is in quotation marks because it's something, a 1. Well, what does that mean? Just like the very beginning. Base and exponent, base and exponent. The exponent says how many times you use the base as a factor. So a to the first power is simply a. 16 to the first power, 16. 47 to the first power is 47. B to the third times A to the fifth raised to the first power raised to the first power is simply b to the third, a to the fifth. So we have the 0 power property, and we have the 1 power, 1 exponent property. The last thing is scientific notation. Everybody in here, everybody has, I'm sure, straight A's. 7 A's, right? I said that before, somewhere else about 7 A's, right? Because you only have 6 classes. But everybody in here is passing their science class with an A. I talked to all of your science teachers, and okay, they were lying to me, weren't they? All right, so everybody in here should remember scientific notation. It's been thrown in your faces for years. It's not just in a science class this year or last year. Way back into elementary school, you heard about scientific notation. It's a shorthand. It's a shorthand, that's all it is. It's shorthand. And what you're going to do, what you're going to see most often is you're going to see it on your calculator with something like this and some sort of symbol with nothing in between, but this implies 10 to the 4th power. In other words, this right here. 3.86 times 10 to the 4th power. What does that mean? It means 38,600. Obviously, this is not so bad. This versus this, not so much a big difference. You also have negatives. Negative exponents, so you have 4.6 times 10 to the negative 3rd power. Well, how do you deal with that? In terms of scientific notation, super simple. This 10 to the 4th simply told me I'm going to shift this decimal between the 3 and the 8 4 places to the right and end up right here. So what about 10 to the negative 3rd? I'm shifting the decimal 3 places to the left. So I end up with this. 1, 2, 3 places to the left from where it was originally. So this number, which is 46 10,000ths, 46 10,000ths, written in scientific notation, is 4.6 times 10 to the negative 3rd power. Shorthand. As I said a second ago, this is not really short. It's when you have on your scientific calculator, sometimes it'll say it like this. There's a key that has that, and it'll have a 3 somehow next to it, or negative 3. But there's a very short way of showing it on a calculator screen rather than times 10 to the negative 3rd, where all you're doing is showing the exponent. That's when you use the scientific notation key on your calculator. It'll write it in a very short form. It won't have all of this. It'll just have that negative 3 somehow displayed. Scientific notation. What can you do with scientific notation? Just like the other stuff. You can multiply and you can divide. So what does that mean? That means when you have something like this, 3.4 times 10 to the 2nd power multiplied by 1.5 times 10 to the 3rd power, what you end up with is rearranging it. Because remember, what is that? One of those properties of multiplication? Commutative property. Commutative meaning you can rearrange it and still have the same answer. So the commutative property tells me that if I'm multiplying this times this times this times this, I can rearrange it so I have 3.4 times 1.5 times 10 to the 2nd times 10 to the 3rd, and here's where my properties or rules for exponents comes into play. This becomes 10 to the 5th, and this becomes 5.1. 3.4 times 1.5 is 5.1. So you can multiply. But look, there's more. Yes, everybody listen up. One more thing, I think. Yeah, just one more thing. Division can happen as well.
So how do we deal with it differently? Not very differently. We can, because these are multiplication, it's not addition, it's just multiplication here and multiplication here. I can split it up into two things. The whole number part, or in this case, rational number part, 4.8 divided by 2.4 times 10 to the 9th divided by 10 to the 3rd. And what's the exponent rule there? This is the quotient of powers property, which says I'm going to subtract 9 minus negative 3 becomes 9 plus 3, 10 to the 12th. That's my exponent. 4.8 divided by 2.4 is 2. So I get a result, of, let's see, I like another color. I like red there. There we go. There's homework. Ta-da! Yeah, whatever. That's the homework assignment. It is posted on School Loop. That's like a school loop. These notes, not my voice, not all the squiggly scagglies, that's posted on School Loop as well, under the locker, in your locker, the Algebra 2 locker. Get started, more later, more tomorrow. This will be posted to YouTube